Right, let's have a look at some revision of grade 11 trigonometry. Just some revision of the concepts of trigonometry. So in general, this is the type of questions we may expect in a grade 11 mathematics paper 2 examination. So they ask about diagram type questions, how to answer diagram type questions. That's number 1.1. Then you may expect application of reduction formulas and core functions. That's number 1.2 and 1.3. You may expect identities. And number 1.4, general solutions. And number 1.5, you may also expect some identities there, general solutions, and some calculations that are based on the basics of geometry. So let's have a look at how to answer this question. And keep in mind that when you are doing revising mathematics, the answers we give are not the important thing. The important thing is the methods we are explaining, so that when you open up an examination paper and you see new questions you have never seen before, you must be able to answer them. So let's have a look at how to answer this question. First of all, make sure that the tan, sine, cos given is the subject of your expression. So here I'm going to move the tan, the 5 to the right hand side, so that I can get 12 times tan b equals to 5. Then we divide both sides by 12, and we also divide this side by 12. Now this will tell us that the tan of b is equal to 5 divided by 12. So what is the idea here? Make sure the trigonometric expression given to you is the subject of the formula. That's what we have done here. Now when you are done with that, we now need to draw the diagram. So the diagram is drawn according to conditions. Now condition number 1 is the value that you are working with in your calculation. So in my calculation here, I have the tan of b, which is equal to 5 over 12. Now you look at the number that you have. We have made tan the subject of the formula. Now we look at this 5 over 12 here. It tells us that the tangent of b is positive. So there is no calculation to do here. You just look at the number to see if it is positive or negative. Now we are going to draw our triangle in a Cartesian plane. So your triangle must be drawn in the quadrant in which tan is positive. And we know that tan is positive in quadrant 1 and in the third quadrant. The second condition, remember there are two conditions to consider. The second one, we are told that B, the angle B, is between 90 and 360. The measurement of angles on our grid, there is 0 degrees, there is 90 degrees, then there is 180 degrees, then there is 270 degrees, and there is 360 degrees when we go back to 0. Now the range that is given specifies that B is somewhere from 90 to 360, which means it can be in quadrant 2, it can be in quadrant 3, and it can be in quadrant 4. Now, out of those conditions, the one quadrant that satisfies both conditions is quadrant 3. So in the third quadrant, we draw a triangle and make a 90-degree angle. Now, the next thing to do is to now label the triangle. The triangle is labeled according to trigonometric ratios of right angles. We know that the tan of an angle is equal to opposite divided by the adjacent. So in our case, we have tan B, which is equal to 5 over 12. It means the opposite is 5 and the adjacent is 12. So the opposite in our diagram is 5 and the adjacent is equal to 12. Very much important here, very critical to not forget. My 5 over 12 are positive numbers. But when I put them in the diagram, they are going to be, the 5 is a negative 5 because the y-axis at the bottom is negative numbers. The 12 is also a negative number because on the left side, the x-axis is negative numbers. So that is minus 5 and minus 12. Now, to carry on, we calculate the third side of the triangle using the theorem of Pythagoras. I'll be trusting that you know how to apply the theorem of Pythagoras. So let's call this side r. Then I can say r squared is equal to 5 squared plus 12 squared. So in a simplified form using a calculator, maybe this can be 25 plus 144. So if you take the square root of these two numbers, it will be 169. If you add them, that's my value for r squared. So therefore, I can say r is equal to the square root of 169, which is equal to 13. Now, this is application of theorem of Pythagoras to calculate the third side of the triangle. Now we know that this triangle, the sides of the triangle are going to be 5, 12, and the third one is 13, calculated using the theorem of Pythagoras. Once you get the three sides of the triangle, you are now ready to answer the question. We want to find the value of sine B plus cos B. Now, the question is answered by substitution. From trigonometric ratios, the sine of an angle is opposite of hypotenuse. So our hypotenuse is 13, the opposite is negative 5. So sine B is equal to minus 5 over 13. Then cos B is adjacent of hypotenuse. The adjacent is minus 12, the hypotenuse is 13. The denominators are the same. If the denominators are the same, we can add the numerators. So the answer to this question is minus 17 over 13. The question 1.1 has been answered. So, important to emphasize is that you must make sure that the trigonometric expression given is the subject of the formula. Your diagram must be drawn according to the two conditions given. When you label it, make sure the numbers are positive or negative according to the x and y axis. The x-axis is negative on the left, the y-axis is negative at the bottom. Then you label the triangle according to trigonometric ratios, and you calculate the third side using the theorem of Pythagoras. Number 1.2. Now let's answer number 1.2 quickly. This one is now reduction formulas. If you see 108 degrees, 360, 108 degrees and the multiples of 180, there is no any ritual there. That is reduction formulas. The 180 falls away and I remain with the sine x. But the sine x that remains there will be positive or negative according to the cast rule. Now, the next one also I've got 180. Some learners have a problem with negative 180. If you don't like this negative, you can simply change it by adding 360 degrees. So if you add 360 degrees to negative 180, this whole angle will become x plus 108 degrees. That is in the third quadrant. So generally the 180 falls away. You are going to remain with the tan x. Now that is 180 degrees. Once again, if you see 180 degrees, then you must know it is going to fall away 180 and the multiples of 180. So the first one is going to, after the removing the 360, I remain with the sine x. But I must check now, is it a positive sine x or a negative sine x? And that is done with according to the cast diagram. The bottom one, if you see 90 degrees, two things happen. The 90 falls away and the sign changes to cos and the cos changes to sine, because this is a cofunction. So the sine of 90 plus x becomes the cos of x. So this is divided by the tan of x. Now I can carry on. So these questions work like this. After applying reductions and cofunctions, the next thing to apply are identities. And we have two identities that we are working with. Cos squared x plus sine squared x is equal to 1. The second one is tan. Tan is equal to sine over cos. So in this fraction right now, I can see that the left part, this fraction can be changed to tan. So that would be a negative of tan x, then divided by tan x. Tan x divided by tan x, the answer is equal to 1. So this is equal to negative 1. That is my question answered. So important is to know how to work with reduction formulas and how to work with cofunctions. So the order in general is that you apply reduction formulas and cofunctions, then you apply identities, and your expression will be simplified to simplest form in that manner. So the question in this case is done. That is number 1.2 for 5 marks. Right, question number 1.3. We want to simplify this expression and show that it is equal to negative 1 as is required. Prove that tan squared 180 plus theta plus 1 over cos 180 plus theta times sin 90 minus theta is equal to negative 1. So this is pretty much the same as the previous question. If you see 180 or the multiples of 180, then remember reduction formulas. So in this question, straight away, there is no any thinking required here. This is going to be tan theta. Now remember, the 180 falls away, the remaining value becomes positive or negative according to the cast diagram. But this one is squared. If it's squared, it is positive irrespective of anything else, because the negative is squared to become positive. Then we go on with the fraction. Cos 180 plus theta, the 180 falls away, so I'm going to remain with cos theta, and my cos theta is a negative cos theta. If you see 90 degrees, 90 degrees is a cofunction. Two things happen. The 90 degrees falls away. At the same time, cos changes to sine, sine changes to cos. So this is the same as multiplication by cos theta. Now from there, we can simplify our expression further. Now remember, we said once you're done applying reductions and cofunctions, the next thing is to apply identities. You have two identities to think about. One, cos squared x plus sine squared x is equal to 1. Identity 2, sine theta over cos theta is equal to tan theta. So here I've got tan squared theta. I can change the tan squared theta into sine squared theta divided by cos squared theta. Then this negative here will make the positive a negative 1. This is minus 1 over cos squared theta. Then I carry on. I have fractions now. What do we know about fractions? We know that when denominators are the same, the fractions can be added. So sine squared theta minus 1 is our numbers in our numerator. Then we write one denominator because the denominators are the same. So this is divided by cos squared theta. This is now our expression. Now something very cute in this expression, the identity which says cos squared theta plus sine squared theta is equal to 1. So let's quickly remind each other that identity again. So it says cos squared theta plus sine squared theta is equal to 1. This is our identity. Now, if we move cos squared theta to the right hand side, we notice that our identity can be expressed as sine squared theta is equal to 1 minus cos squared theta. And this is another way in which we can express our identity. Then we also notice that if you move sine, then you'll get cos squared theta is equal to 1 minus sine squared theta. So if you see 1 minus or 1 and a negative cos, then you may have to think about this identity. Now, if I look at my formula, there is 1 minus sine squared theta. But in my expression, there is a sine squared theta minus 1. If that happens, you use the factorization to work it out. So your expression, when you are doing factorization, you factor out negative 1. So from the top expression, you factor out negative 1. The negative 1 that we factor out will change this sine squared into negative of sine squared theta. And then the negative 1 will change into positive 1. This is divided by cos squared theta. Then to carry on from there, minus 1. If I rewrite this expression starting with a positive, then it will be 1 minus sine squared theta. So 1 minus sine squared theta divided by cos squared theta. 1 minus sine squared theta is the value of cos squared theta. Therefore, this is equal to negative 1 factor of cos squared theta and divided by cos squared theta. Then this is equal to, if I divide cos squared theta and cos squared theta, the answer is negative 1. This answers question number 1.3. My calculation is a bit long. I've made it long to just try and avoid confusion. But if I'm working and I want to be a little bit fast, I should know in my mind that if an expression, for example, says sine squared theta is equal to 1 minus cos squared theta, if they switch these numbers into cos squared theta minus 1, then I must know that my identity on the left side is a negative. So this is the same as negative sine squared theta. So we have answered question number 1.3, proving that the identity is equal to negative 1 when simplified. Number 1.4, determine the general solutions of the given equation. Now, these equations can be expressed in so many different ways, and therefore there are so many different methods that can be applied in solving the equations. There is one video that we have sent here on general solutions that may go through so that you may get an idea about certain general solutions. Right, this one, if we have only two terms, we can borrow ideas from algebra. Let's say, for example, we have an equation that has got two terms and we want to solve that equation. Now, we can solve this equation by factorization. There is a common factor x here, which we can factor out to get x factor of 2x minus 1 is equal to 0. Then after that, we equate each factor to 0 to get two solutions. So x is equal to 0 or x is equal to 1 over 2. So we can use factorization because there are only two terms. Now if we look at this equation, the first one, this is one term and this is another term. From the two terms, there is a common factor of cos x. So if you factor out cos x, we remain with the 2 times the sine of x minus the cos of x. This is equal to 0. Then from there, we equate each factor to 0. That means cos x equals to 0 to form its own equation. Then 2 times the sine of x minus cos x equals to 0 to form another equation. Then we solve the separate equations. Now, of the two equations, the first one, cos x is equal to 0. This one can be solved very easily. So let's carry on with this second one first. If you get an equation that has got sine x and cos x with no any other numbers added to the equation, then you can solve the equation using the tan identity. We know that tan is equal to sine over cos. So to use the tan identity, you divide the equation by cos x, everything by cos x. Even the 0, we also divide 0 by cos x. Sine over cos is equal to tan. So this is the same as 2 times tan x minus cos over cos x over cos x is equal to 1. This is equal to 0 over cos x. That gives us 0. Then from here, we move the 1 to the right hand side. We get 2 times tan x is equal to 1. Then we divide both sides by 2 to get the tan of x is equal to 1 over 2. That is our equation in simplest form. We are now at tan x is equal to 1 over 2. Right, now that we have simplified it, we need the reference angle. So the reference angle from here is something that you can do with a calculator. So get your calculator and determine the reference angle for this equation. So this is equal to 26.57 degrees. And remember, this is using a calculator. Then to determine your solutions, you need to check the trigonometric expression you have in simplified form. Tan x is equal to 1 over 2. Tan x is equal to 1 over 2. That 1 over 2 is positive. So what you need to do now is to read your answer from the quadrants where tan is positive. Tan is positive, so you must read your answer in the quadrant where tan is positive. So tan is positive in quadrant 1 and tan is positive in the third quadrant. Now in quadrant 1, the value of our angle is theta. In quadrant 3, the angle is 180 plus theta. Quadrant 1 and quadrant 3. So the value of x is equal to theta. In quadrant 1, the angle is theta, so x is equal to theta. In place of theta, you put the reference angle. So x is equal to 26.57 degrees. The next solution, is now in the third quadrant. That's where tan is positive. It's 180 plus 26.57. So 26.57 is in place of theta. So that will give us 206.57. These are general solutions. So for general solutions, for tan, we add 180 times k, and this one is also 180 times k. Let's not forget our cos x is equal to 0. There is also a solution there, and this one from special angles we know it's 0 plus 360 multiplied by k, and in each case k is an integer. That is our general solutions. That is our equation answered. So it is something that we may look forward to in a grade 11 mathematics paper 2 examination. So we have just answered number 1.4. Let's go to the next one. Question number 1.5. Now this is straightforward, but if you are not careful, it can look like something difficult. We should know that using a calculator we can determine this. Even without a calculator, we need to remember our special angles. So we know that tan 45 degrees from special angles, tan 45 is equal to 1. So definitely that means x plus y divided by 2. This is equal to 45 degrees because tan 45 degrees is equal to 1, and we have been told that the values of x and y are acute angles. Then the next one, we know that the cos of 60 the cos of 30. Cos 30 is equal to root 3 over 2. So therefore x minus y is equal to 30 degrees. And there we are. That is our calculations. Then we can go ahead. The first equation is x plus y is equal to 2 times 45, which is 90 degrees. So then I can use substitution to work this out. Y is equal to 90 degrees minus x. So I bring this into the position for y in the other equation. X minus y will become x minus 90 minus x. This is equal to 30 degrees. Then carrying on from here, this is x minus 90 plus x is equal to 30. This is now basic calculations. So 2x is equal to 90 plus 30 is 120. Dividing both sides by 2, x will equal to 60 degrees. Then I will come here and find y. Y is equal to 90 degrees minus 60. 90 minus 60 is equal to 30. Then I've got my two values for x and y. Straightforward, just looks intimidating, but otherwise is something that we can definitely do. Even on a calculator, if I say this is my answer, I'm just explaining just a little bit to bring more clarity. If I say tan A is equal to 1, then using a calculator, the value of A can be determined because the question specified that A is an acute angle. So this can give us the answer. A is equal to 45 degrees. So in the first equation, we did exactly that, where we can say the expression given. Using a calculator, we can determine the value that we need, and that is where our 45 comes from. So this is equal to 45 degrees. So by now we have answered the whole question from 1.1 to 1.5. This is a good example of a trigonometric examination question at grade 11 level.